Hi guys, okay, we'll be looking at the Chateliar's principle. The Chateliar's principle states that when a system in equilibrium is disturbed, the composition of the equilibrium shifts so as to remove the disturbance. So we're going to look at three scenarios, three factors which actually affects the equilibrium of the system in equilibrium. Okay, the first is concentration. So here I just have a general expression of an equation where A will be reacting with B to give us AB. Okay, so if this is an equilibrium system, we are saying equilibrium is a dynamic equilibrium whereby the rate of the forward reaction is similar to the rate of the reverse reaction, which implies that the concentration of A and the concentration of B and the concentration of AB are similar, but the reaction is still going on. That is actually dynamic equilibrium. So we are saying if we say increase the concentration of A, if we will take A from somewhere and then we add it to the equilibrium will try to remove A. Hence, this equilibrium will shift towards production of more AB, so as to try to reduce the amount of the A plus which has been added. So that is what we are saying. That is what the Chateliar's principle states, that it will be trying to actually remove the disturbance, so as equilibrium will still be achieved, whilst you don't have, like whilst you have catered for the extra A. So say we add A into a solution which has got this equilibrium, it will move until it is established yet another equilibrium, that is now with a concentration of K which is normal, with A of A which is normal. Then you go on to temperature. Okay, let's say it's an endothermic reaction. An endothermic reaction is the reaction which actually releases heat into the environment, hence it has got a delta H negative. So let's say this reaction of A plus B to give us AB is endothermic. That means it releases heat into the environment. If we increase the temperature, that would imply that we are giving it more heat. Whilst the forward reaction actually releases heat into the environment. So what we do is, what will happen in the equilibrium, it will then favor the reverse reaction, which actually takes away heat from the environment, so as to try to mitigate this disturbance which has been caused to the equilibrium. And then if it is an endothermic reaction, an endothermic reaction is a reaction which actually takes away heat from the environment. So if we increase the temperature, or if we add heat, what will happen is it will then like to take more heat away from the environment. Hence, the forward reaction will be favored. That implies that for the exothermic, if we actually reduce the temperature, the forward reaction will be favored, so as to actually increase the temperature of the environment. And the same for the endothermic. If we actually reduce the temperature, what will happen is that the backward reaction will be favored, so as to reduce the energy which is also being taken from the environment. Now, coming to pressure, I have used this equation, which is normally in the conduct process, whereby sulfur dioxide will be reacting with oxygen to give us sulfur trioxide. So we are saying the number of moles this side is 2 here and then 1 here. Well, actually, you've got 2 moles here on the sulfur trioxide side. So there are 3 moles of gas at the left-hand side of the reaction. We've got only 2 moles of gas at the right hand. So what happens is, if we increase pressure, you know, the volume and pressure are directly linked. So that if we increase pressure, it will try to reduce the volume, so as to reduce the pressure, so the forward reaction will be favored. And if we, however, reduce the pressure, the backward reaction will be favored, so as to actually maintain the pressure, so that the equation will try to increase the volume, so as to maintain the pressure. Ladies and gentlemen, the Chateliar's principle states that if a system in equilibrium is disturbed, it will try to move towards the removal of that disturbance. And I've just explained how that takes place in all 3 scenarios, that is with concentration change, temperature change, and pressure change.